All right, let's jump right in. You turn on the tap and you probably don't give it a second thought, but behind the scenes, there's this constant, high-stakes battle going on to keep our water safe. So today, we're going to pull back the curtain and go inside the anatomy of an emergency response to a toxic spill.
I mean, it's a pretty terrifying question, right? A chemical spill, an illegal industrial dump. What actually goes down in those first critical hours when a dangerous contaminant threatens the entire system?
Well, the best way to picture it is like this. Suddenly, that treatment plant isn't a plant anymore. It's an emergency room for the environment. The operators, they're the first responders, and their patient is our water supply. Their one and only goal, stabilize the system and prevent an absolute catastrophe.
And these things, they can come out of nowhere. One minute, everything's running smoothly, and the next, a tank or truck is overturned on a bridge, or some factory has decided to illegally dump its waste. Whatever the cause, the result is the same, a massive, sudden shock to a system that just wasn't designed for it.
Now, to really grasp what's at stake here, you have to understand a treatment plant isn't just pipes and concrete. It's actually a living thing. Think of it like a bustling city of trillions of good guy microbes, all working 24/7 to clean our water. So a toxic spill? Whoa, that's like a chemical weapon attack on this microscopic city. And it can cause a total system collapse.
So how in the world do you fight something like that? Well, it all starts way before an alarm ever goes off. Effective crisis management is 100% about proactive preparation. You just can't improvise your way out of a chemical spill.
At the absolute core of their defense is a document called the Emergency Response Plan, or ERP. And please, don't picture some dusty old binder on a shelf. This is a living, breathing playbook that's constantly being updated and tested. It's the foundation for literally everything that happens next.
And this playbook is incredibly detailed. I mean, they start by gaming out every possible nightmare scenario you can think of. Then, they define exactly who's in charge, who calls who. They create this whole communications tree for everyone, from the plant operator to the EPA. And they inventory every single piece of equipment they have, right down to the last containment boom. A huge part of all this is managing what local industries are discharging. The goal is to prevent two key types of failure. The first is interference. That's when a pollutant gets in and just wrecks the plant's biology. But the second one, pass-through, is honestly even scarier. That's when a poison goes right through the plant untreated and out into the environment. Both are total disasters. Okay, so let's move into the action. The alarm has just sounded, there's a potential threat in the system, the clock is ticking, and every single decision matters. This is the moment where all that planning gets put to the ultimate test.
So how do they even know there's a problem? Well, the first clue can come from anywhere. It might be a digital alarm from a pH sensor going crazy. Or it could be an operator's own senses. Noticing a weird color in the water, a strange chemical smell, or seeing the aeration tank suddenly start to foam up. They're using both technology and instinct to catch it fast.
And once that alarm goes off, things move with incredible speed. First, you get the alarm. Immediately, a team moves to confirm the threat, grabbing rapid samples. At the exact same time, field crews are racing out, popping manhole covers to isolate the source. And the whole time, the #1 mission is to contain the damage and save that microbial city.
And the response is super specific. This is not a one-size-fits-all solution. If it's, say, an acid spill that's crashing the pH, they hit it with chemicals to neutralize it instantly. If it's a toxic organic solvent, they'll add something called powdered activated carbon, which basically acts like a giant sponge, soaking up the poison before it can do any real damage.
Sometimes the choices they have to make are just brutal. As a last resort, operators might have to sacrifice a single treatment unit. They'll isolate it, let the contamination run its course, and basically let the microbes in that one section die to save the other 90% of the plant. It's a terrible calculation, the cost of rebuilding one unit versus the catastrophic cost of a total system failure.
And right in the middle of all this technical chaos, this one principle is absolutely paramount. Operators immediately notify regulators and public health officials. They communicate what they know, what they're doing, and what the risks are. Trust is an absolutely critical part of managing a crisis.
Okay, so once the immediate danger is over and the system is stabilized, the work isn't done. Not even close. The pace shifts from that frantic action to a very methodical recovery. It's time to heal the system and, most importantly, to learn.
And this part is so important. The response doesn't just end when the spill is contained.
every single crisis becomes a lesson. The team debriefs every decision. They launch an investigation to find the root cause. And then all those lessons get folded right back into that emergency response plan, making it even stronger for the next time.
So, what does all this really add up to? Well, it's not just about surviving a single bad day. It's about building a system that is fundamentally resilient, one that can take a hit, recover, and actually come out stronger on the other side.
So, what's the formula for success? It really boils down to these 6 pillars. It's a continuous loop that starts with that robust pre-planning, long before anything goes wrong. Then, in the heat of the moment, it's all about rapid detection and swift containment. But you also need the flexibility to adapt on the fly, and you've got to have that clear communication. And finally, it all feeds back into continuous improvement, so you're even more prepared for the future.
All of this really brings us to one final, critical question. This complex, high-stakes emergency preparedness is happening in communities everywhere, probably in your own backyard. And it makes you think, how prepared are the silent guardians of your water?